Good afternoon, everyone from Standard Maths. I've had my day over in Lismore and now I have my cup of tea. So I am ready to go with volume of cylinders. Now, cylinders we put separately to the right prisms that we did yesterday, but realistically, it's the same formula. So you remember yesterday, the formula for a right prism was that volume equals the area of the base times by the height. Now, if we look here at this little part of the formula here, well, that's the area of a circle. So that's the area of the base times by the height. So it is essentially just the same formula. We just have to allow for the fact that we're just doing it separately because it's a cylinder. I don't know why. So it should be relatively simple. Like always, when we're dealing with circles, we've got to remember, are we looking at a diameter or a radius? And in this case here, the very first equation they've given has a diameter. So I'm going to need to halve that to come up with my radius. So like always, best practice is to write the formula down before we start. So volume in this case equals pi r squared h. So obviously pi is a number, we can just leave it as a number. Our radius in this case is half of what's listed there. So the diameter is 6, so our radius must be 3, and we square that. And then we're timesing that by the height, which is 10. We plug all that into our calculator, which I'll just bring up here, and we've got pi, mistake there, shift, pi times the radius squared times by 10. And that gives us that 282. Oh, I missed the very end of that number, 0.74. I'll call that 0.74. We'll go to 2 decimal places. How's that sound? And again, we look at the units, and it's at centimetres, and we're talking about volume, so we're talking about centimetres cubed. All right. So going on, the next question is actually easier than the first. It's just the cylinders on a different angle. So once again, we use that formula, volume equals pi r squared h, and in this case, pi stays the same. The radius is actually given this one, so that's 42 millimetres, and we times that by the height of 26 millimetres, and I just have to stop my daughter from stealing my cup of tea. Right, so we move on and we plug all that into the calculator. So pi times by 42 squared. Oh, hang on, let's just check something. I'm pretty sure we're right though. Times by 26 being the height. And that gives us 144,086. And I'll round that to a whole number, so we'll just go with 144,086. Millimetres cubed. Now the reason why I just hesitated there when I was with the calculator is in the calculator I could not see whether or not that 26 millimetres was millimetres or metres, but I guessed from the picture that it was millimetres. Obviously, we've got to make sure that we're dealing with all the same units before we start to use the formulas. So the third example here is to find the volume in this half cylinder. The easiest way to do that is going to be to find the volume of the whole cylinder and halve the result. So we just want to go with half of the volume of the whole cylinder, which would be pi r squared h. All right, so we'll just leave that half out the front. Because it's all multiplication, we don't really need the brackets, but it helps to make sense of it all. Now this 4 centimetres, well, that's going to be the diameter, so radius is going to have to be 2 centimetres, isn't it? So this is going to be pi times 2 squared times by 10. Now it's really important when substituting in the formula that we get the radius and the height in the right spot, because we don't want to square the height, we want to square the radius. It will change the result. So once again, we plug that into the old calculator and we'll get a half outside of pi times 2 squared times 10. We close our brackets there, and that'll give us our answer, which I'll round to 2 decimal places and we'll say 62.83. So I'll just write that in there. 62.83, and we're in centimetres, and we're talking about volume. Volume is to deal with 3-dimensional objects, and look at that, it's cubed. We put a 3 after the centimetres. Okay, so the next one is the Chloe Bodley special. She wanted to know the answer to this the other day when we were in class, and I said we'd get there. So for this one, we've got a washer. So we've got basically a cylinder, a big cylinder with a small cylinder cut out of it. So to find our volume of this one, we're going to need to know the volume of that big cylinder, and we're going to have to take away from that the volume of the small cylinder. And I'll just enhance that with a bit of highlighting, because highlighting's fun. So there we go there. When I'm talking about that yellow bit, I'm talking about this big cylinder, the big object on the outside here. Okay? I'm not going to colour it all in because I need to make sure I make it clear that we're dealing with the small one. And then the bit I'm taking away is the volume of the small cylinder, which is this little fellow in here. All right? So that's kind of the hollow part. So if I go back now, and I choose my pen. Okay, so just checking first, are we all in centimetres? Yes, we are all in centimetres. All right. So our height for both of these cylinders is going to be the same. All that's actually going to change in both these cases is our radius. So the first one is pi, and our radius of the large cylinder is given as 2.7 centimetres. So times by 2.7 squared, and then we multiply that by the height, or the thickness in this case, which is 0.5. Then we're going to take away from that the volume of that little cylinder that I've highlighted in blue, so the area that's been cut out. And for that, the same formula, so pi times the radius. The radius in this case is 0.8 of a centimetre. Squared, that's a 0.8. Sorry if that looks a bit messy. Actually, I'll just go back. I'll fix that up. There we go. Silly little button on my pen, which if I hit makes my writing even worse. And then our height is the same, so that's 0.5. Okay, so we're going to key all of that into the calculator, and we can do that all as one line in the calculator. Our calculator's smart enough to work that out. So we're going to start with pi times by 2.7 squared times by 0.5. Or you could put 0.5, it doesn't really make a difference. The calculator will take it either way. Times by minus the pi times by 0.8 squared times by 0.5. Once again, you don't have to put this, you can go 0.5 there, but the calculator will be happy with just 0.5, that's fine. All right, so we press equals and we end up with our volume of the washer. And that's 10 point, I'm going to go 45 there, round to 2 decimal places. So 10.45 centimetres cubed. Now, you could work out the volume of one, then work out the volume of the other, and get a result for the first one, get a result for the second one, and then minus one for the other. That'd be fine too. But as long as you're careful when you key it into the calculator, you can do it all in one foul swoop there. Okay, so the final question we've got here is from a previous HSC paper from 2017. And we're given a concrete water pipe is manufactured in the shape of an annular cylinder. The dimensions are shown in the diagram. So what's the approximate volume of the concrete? What is the approximate volume of the concrete needed to make the water pipe? So what we're interested in is we want to know the area. I'm going to do this one slightly different to the last one, which we could have done this way as well. Like I said at the start, and if I roll back up here, we are just looking for the area of the base, and we can multiply it by the height. And in this previous one here, you could see that both were multiplied by the same height. I could have just worked out this area minus that area, then multiply the result by that height. So that's the way I'll do this one, just to show that you can work in a couple of ways and it works out. So what I need to know first, in order to find the volume, is to find the area of the base. Now the area of that base is going to be this large cylinder on the outside, take away this small cylinder on the inside that's been cut out, or this small circle on the inside. So we want to know this large circle, take away the area of that small circle. So I'll just put that, I'll start up here and I'll say, so base area equals, and I'm just going to say big circle, take away little circle. I'm running out of room, I'll just move across a little bit. There we go. Pointer back and we can put an E on there. Fantastic. All right, so my big circle, the area of that's going to be pi r squared. So my radius, my big circle, is this full 0.35 meters plus this extra 0.1 of a meter. All right, so I'm actually going to be 0.45 meters. So times by 0.45 squared. And then I'm going to take away from that pi times by this smaller circle, which is 0.35 meters. So 0.35 squared. So when I plug those into my calculator, so we're going to have pi times by 0.45 squared, take away pi times by 0.35 squared equals, and now this is the area of my base. This isn't the volume, this shouldn't be the end answer we're looking for. So we're looking at 0.25 meters squared. Now I'm going to keep that number on my calculator because this is just a 2 decimal places. So I'll keep the number on my calculator because that's going to be a little bit more exact. So now that I know the area of this base, I need to multiply it by the height. So the volume is just going to be area times by the height. Now I already know my area, that's that 0.25. And I'm going to multiply that by how long it is. Now we're all in meters here, so we can just multiply as is. And we've got 2.8 meters of height. So I can take that figure I just had before and multiply it by 2.8. So I'm going to take that answer and multiply it by 2.8. And that's going to give me an answer of 0.704. So 0.704 to 3 decimal places. And I look over here at my answers and lo and behold, look at that. That one looks pretty close to what I've got calculated there. So that's our answer. All right, now just bear in mind that when you're doing this, depending on what you've rounded to here, can affect your answer here. So it's best not to round until the very end. But if you do and you're close, probably pick the one that you're close with because that's going to be more likely to be the right one. All right, so that's the end of that lesson. If you've got any questions regarding the bookwork, feel free to post them on Classroom or ask me on Friday. Have a good day tomorrow.